Welcome to Math 2318, Section 1.7. In this particular section, we're looking to see if vectors are linearly independent or if vectors are linearly dependent. What does all that mean? So we are given three vectors here, a1, a2, a3. So what we'd like to do is to form C1A1 plus C2A2 plus C3A3 and set that equal to 0. C1, C2, C3 are any real number we like. And the question is, when I form this combination of vectors and I set it equal to 0, is this only true if C1, C2, and C3 are all 0? Or is it possible that at least one of these vectors can be written as the sum of some combination of the others? So the way to do this is we see if we can solve this equation for C1, C2, C3, and we see if the trivial solution is the only solution. All right, so looking at my matrix, I'm going to row reduce this. I don't have a 1 here, but I don't want to divide by 6 and make fractions, so I'm going to leave the 6 there. Looking here at row 2, I want to make a 1 there. That's easy. Divide through by 4. And now I'm going to use this 1 to make a 0 above it and a 0 below it. So multiplying by -7 and adding, multiplying by 12 and adding. So doing that, I get a 1 and some zeros. On the last row, I'm going to divide by -8, giving me a 1. And then when I do that, I use the 1 to make some zeros above it. And when I do that, I see that the only way this combination is 0 is if C1, C2, C3 is 0. And that's the only solution. Therefore, these three vectors are linearly independent. All right, in question 2 here, we have two vectors. Question is, are they linearly independent or not? So again, C1V1 plus C2V2 equals 0. Is this only true if C1 equals C2 equals 0? Is that the only time that this is true? All right, so with this problem, this is easy to row reduce, divide this particular row 1 by 2. I now will use this 1 to make a 0 underneath it. And when I do that, I see, well, I get a row of zeros. So what that tells me is these two vectors will sum to 0 anytime C1 is equal to C2. So for example, if C1 is 1 and C2 is also 1, I add them up and I get the 0 vector. So these two vectors are certainly not linearly independent. All right, so in this case, we have three vectors. And so I want to know for what values of h, here's h is sitting in there, is V3 in the span of the first two. So let's see. Well, that would mean that something times V1 plus something times V2 is equal to V3. They are linearly dependent. So let's take a look. So we form the matrix. So here's my matrix. Here's H that we want to keep our eyes on to see what happens. All right, so let's see, row 2, I see I can divide that by -4. Row 3, I see I can divide through by 3. All right, so now the goal is to use this 1 and make some zeros. All right, so we do that, and in the process, I see the following. So I don't have anything, any kind of a 1 in this second column. So I'm going to divide row 2 by -7. All right. And by doing that, now I'm looking at making a 0 top and bottom. So I want to use this 1 to make a 0 and make a 0. And so when I do that, I get this situation. I get a row of all zeros. So looking at H here, H was never in a position to be undefined. So solving this, I see C3 is 0 from this position. So from there I see that. And I see that C1 is equal to 2 times C2. So that tells me that the sum of these two is 0. So V3 is not in the span. And they are linearly dependent no matter what H that we pick. They are always dependent. All right, let's see. Question 4 here. For what values of H are these linearly dependent? All right, so again, I form the matrix. I look at what I have. I'm dividing row 3 by -2 to clean it up a little bit. And now I'm going to use this one to make some zeros. All right, did that. All right, we have a 1 now in this position. I'm going to use this one to make a 0. And again, I'm looking to see how H is involved in the process. I do have a row here of all zeros. And so what I see is that C3 is free. C2 is 12 minus H times C3. And C1 is 32 minus 3H times C3. So what I see, so this is how we got that business about the 32. So these three vectors are linearly dependent for, again, all possible choices of H.